Okay, thank you so much for reminding me. I totally forgot. So this is an example of a Crimebusters test that I took this year. Each time they will give you a scenario or an example of a crime. So for here it's called the stolen math final, in which Mr. Calculus is giving his students some questions, but he realized that someone stole the scantrons. And then there are suspects given with pen fingerprint, pen ink, fingerprints, shoe prints, and there are tons of bios for many different suspects. And basically, you're supposed to identify all these things, piece together all the evidence, and then do the final analysis. I do not know if I have the permission to share this type of stuff. So yeah, I probably can't share this. So on the test, there are three major sections of it. So the first part is the chemical identification section. That includes things like powders, polymers, liquids, metals, hairs, fibers, mixtures. For time's sake, I won't be covering polymers. They're basically just plastics. Part two, chemical analysis, is just fingerprints, chromatography, DNA, shoe prints, tire prints, soil, blood splatters. Blood splatter is my favorite, but we won't be covering it. We also won't be covering soil and shoe and tire prints. The final part is called the final analysis, and that is where you do the chemical and evidence implication, you say the possible motives, and you do a crime scene reconstruction. Before COVID, I believe that they did give you the a real microscope and like real soil and real DNA and real like pen ink and fingerprints to play around with. In the online tests, all they do is just provide images of them. Am I going to give you problems? Yes, I am. It's not exactly harder online. I think it's actually easier online because you don't have to do all the setup. All you have to do is look at the evidence and determine what it is. So the first part is powder identification, and it's the biggest part of the identification section. And the two strategies for tackling powder identification is just either memorize it all or put the chart on your cheat sheet, which I will show later. And for powder identification, all you need to know is just know the color, acidity, and all this type of stuff for each type of powder. So here I have sodium acetate, which is used to make hand warmers. And its crystal shape is irregular, it's white, it is soluble, it has a pH of A, it does not react with HCl or iodine. It has this really complex formula, and it is exothermic, or it releases heat when you mix it with water. One thing that I would like to know about is that these pHs aren't usually actually right. Because of different manufacturers, each pH during the test might be different. I encountered a test where they said the pH of sodium acetate was 6. So it really varies a lot. So here I have a practice of identifying powders. Here you have a chart, and this is the evidence that they give you. And using this evidence, try to identify which powder S number 1 is. Okay, I am getting some correct answers. Yeah, I'm getting a lot of correct answers now. So the main points to look at is that it creates a solid liquid mixture and it turns dark blue/black in iodine. Can you go back to the previous slide? Okay, sure, I'll do it really quickly. Screenshot it. 3, 2, 1. Okay, back. So yeah, again, the main clues here is the water and the iodine. You can see that the only ones that react with iodine are just 5 different powders. And with the fact that it creates a solid liquid mixture, you can narrow it down to cornstarch. Good job to all of you who got it. I'm pretty proud of you. So the next part is liquid identification. Usually a test won't have lots of questions about liquids. It's just you just know the color, acidity, odor, reactivity, all that same stuff. I have two examples here. They're pretty obvious sometimes. For example, lemon juice is acidic and it is yellow, of course. And of course, it smells like lemons. Uh, Again, the pHs aren't usually really like standard. It always varies a lot. Rubbing alcohol can be slightly more acidic or basic. And there are some things that may not even make sense. Um, for example, I won't agree that rubbing alcohol smells sweet, but basically you use this chart to identify different liquids that they give you. For metals, it's almost just the same thing. It also isn't quite like it. There aren't much questions about metals in the test itself, but you also just use a chart to figure out what metal is what. So here you have aluminum and it has a light density, which is why they use it in airplanes. And it actually reacts with hydrogen chloride, which is cool. Something to note about is that uh, the only magnetic metal in the entire test that they can give you is iron. Every other metal that they can give you is not magnetic. Here's is really cool. So in the test, they'll just give you an image of the hair under the microscope. It can be a cross section or just a exterior image. And the Crimebusters test is only allowed to give you dog hair, cat hair, or human hair. And the notable characteristics about cat hair is that there's little tiny circles. There's little tiny circles, as you can see, on the cat hair. And that makes up its medulla or core. Cat hair also has a really scaly exterior like bark on a tree. The notable thing about dog hair is that it has this really thick medulla. This black thing hair is an extremely thick medulla that you probably won't find in many other places. When it's class ending, class will end in 30 more minutes. The noble thing about human hair is that it has absolutely no core at all. You don't see little tiny balls. You also don't see a thick black line. All you see is just normal brown stuff inside the hair. And here I have a practice for hairs. You can refer to these three images to try to find out what this type of hair is. Yeah, I'm getting so many correct answers right now. Yeah, I don't even see an incorrect answer. So there are little tiny balls you can see here, and that is the same thing as the little balls that you see in the cat hair. And you can also see that its like exterior is a bit scaly, which also corresponds to this fellow. Great job, everyone. Fiber identification is just like hair identification. There's three types, namely animal fiber, vegetable fiber, and synthetic fiber. Sorry. Animal and vegetable fiber are both natural fibers, which means that they grow on plants or trees, or even animals. So wool or silk or cotton or linen, they're found everywhere on clothing. Synthetic fiber is made from factories, and they are stuff like nylon, acrylic, polyester, rayon, just all the stuff that you find in super cheap clothing. Those things usually aren't as comfortable as natural fibers because they're synthetic and artificial. And the main way to differentiate between natural and synthetic fibers is just looking at how rough the exterior is. The first 7 fibers here are all types of natural fibers. And you can see that they're either super rough or they're twisted. You can see that cotton is both rough and twisted. Silk is pretty smooth, but it's twisted. Cashmere is really rough, so is coarse wool. But when you take a look at polyester, not only is it straight, but it's also super smooth, and that's because it's made out of a factory. Um, so here is a quick example. Say that crime scene, you found this fiber lying around, and under a microscope, you see that it looks like this. And given this type, can you try to identify what type of fiber this is? So I'm getting some different answers here. So I don't know specifically what type of fiber, what type of vegetable fiber this is. This might be cotton or silk. I think it's silk actually. But the main thing that you should know is that this thing is the vegetable fiber because it is twisted. Okay, good job, everyone. So fingerprints are also really cool. There are three types of there are three different patterns within fingerprints that you should know about. And it's just arches, whorls, and loops. Arches are the most rare of all. If you see an arch in one of your fingerprint, like right in the dead center, you're among, I think, like 5% of people. 10 arch is a even more rare type of arch, and it's just steeper. Whorls are really, really common, and so are loops. Whorls are just a whorl, and loops are just loops. Those things are the most common of all. And other than just identifying suspects through fingerprints, I think something else that I found really cool is that you can detect drug use from the type of oil on the fingerprint. So when you find a fingerprint, you can actually detect whether or not a person is taking drugs or drinking alcohol just from the fingerprint oil itself. Someone asked, is it common to have a whirl loop combination? Probably yes. I have both whirls and loops. Someone also asked, what is the rarest? 10 arches, I think, are the rarest of all, but arches are also really rare. And people are also currently studying how to identify even more stuff through just fingerprints, such as ethnicity, sex, dietary patterns. So in the future, if technology gets super good, then just from a fingerprint, people might know that you're a girl who is like what, a teenage girl who just ate like broccoli 2 hours ago. And the ways to extract fingerprints is there are many ways actually, such as dusting, photography, fluorescent dye, and chemical reactions. Um, and after you extracted the fingerprint, ways to differentiate fingerprint other than these three types of fingerprints are just these three things. These are deltas, where they form a little triangle. These are just little, really short lines in between two parallel other lines. And these are when lines stop. Those are ways that you can differentiate between two types of similar fingerprints. Uh, so chromatography is a way of analyzing ink. So the situation usually is that they say that, on the crime scene, they saw a Sharpie ink and they think that the Sharpie ink is the same brand that suspect C uses. Can you do chromatography on this pen that suspect C uses and the ink that you found on the crime scene to see whether or not suspect C actually did that ink? And the process is chromatography, where you first put that ink onto a paper towel, and then you add a solvent such as alcohol, and then let the ink slowly spread out. Hopefully the audio will come out
We'll
this time.
start our experiment by drawing a line with the marker on the chromatography paper. Then what we want to do is insert that chromatography paper into a beaker with a small volume of water in it. We can see that the water will start to rise up the chromatography paper because of capillary action. You'll note this happening very quickly because this is 16 times speed playback. We can see that the ink, which originally looked black, is starting to separate into different colors. This is because the different pigments have different properties. Some of them are heavier, some are lighter, some are more soluble in water, some are less. Because of these differing properties, all of the different colors are going to travel at different.
Okay, great. The audio actually came out this time. So you can see that basically the solvent bonds with the ink itself, and it allows the ink to separate because each component of the ink individually bonds with the alcohol. And there are some types of ink, such as here, the black ink, that moves considerably faster because it bonds easily compared to other colors such as yellow. Yellow here, obviously,
Is it
yes,
possible to detect blood or something?
detect water.
Like blood.
I don't think so because blood isn't like uh number one, I think all the components of blood looks like exactly the same color. I'm not so sure. But if for some reason blood has different components with different colors, and each component has different bond strengths with alcohol, then maybe you can separate blood. There are easier ways to separate blood. There's this way of you where you spin the blood really quickly to the point where the individual things just separate by themselves.
Oh,
Uh,
and then what if someone like leaves no fingerprints or anything
oh,
somehow? Like if
so
they sanitized it first. Or maybe
yeah, that's so fingerprints is like not leaving fingerprints, although it's like almost impossible. Of course, it is possible that the criminal is smart enough to not leave any fingerprints at all.
Yeah,
Uh,
yeah. So
Or
yeah,
wearing
so
gloves.
like yeah, so like if like say you're away on vacation and someone robs your home, they have a lot of time usually so that they can just steal everything and then they can just erase all the evidence.
uh, I think I can't recall correctly, but there is a law in forensics. I forgot what the law is called, but the law basically says that you leave a trace of evidence no matter how much preparation you do. I think you can search up the law. I forgot the name, but it basically just says that it's impossible to not leave any evidence at all. There will be always some sort of evidence, such as fingerprints or DNA evidence or hair evidence that you accidentally leave that you didn't find out. YAS says, what kind of art thing are they using, Sharpie or marker? I think they're using marker in this example. Will egg yolk work? Probably not. How would this help solve a crime? This helps solve a crime because, as I said before, there may be a situation where they say, hey, we found uh, Sharpie ink on the crime scene. Let's say that it's like yellow Sharpie ink. And we think that this yellow Sharpie ink is pretty similar to a Sharpie marker that suspect C has. And in order to have evidence saying that this ink connects to suspect C's Sharpie marker, you have to use chromatography and do it on both the marker and the ink found on the crime scene to see whether or not they match. I'll have an example on the next page. Is that Specs P? Probably not. What if they wore gloves? Uh, but the gloves themselves might have fingerprints when you wear them. And yeah.
We'll
So
start.
as I promised, here is an example of an actual test where the chromatography can anybody see which person's chromatography matches with the crime scene.
E.
Yeah.
E.
Yeah, I see lots of correct answers right now. Next time, do it through chat so that other people can also have a chance. Both E and F look quite similar actually in terms of the upper side, but the main thing that differentiates them is this part. And that's the reason why F does not have a similar thing. So here, crime scene is what they found on the crime scene, and E is just the marker that they obtained from E to see whether or not it matches. Next is DNA analysis. DNA in a crime scene can be found in so many different ways. It can be found in blood, in saliva, in hair. Your skin also constantly drops dead skin onto the ground. Those things you basically cannot avoid at all because how like small and minuscule those dead skin particles are. And basically, through any one of those, you can obtain DNA. Unfortunately, DNA analysis is quite inaccurate. You probably know of the statistic about how 99, like each person's DNA, everyone's DNA is 99.99% similar. So it's really hard to find out the differences between two different people's DNA. Uh, and for DNA analysis, gel electrophoresis is commonly used. So here is the machine that is used to do it. You put different DNA evidence onto the wells, and then you run electricity through a gel, and basically the DNA will slowly start separating when the power source becomes active. It's just like chromatography, but instead of adherence to the gel, instead the separation of DNA is a uh, is about how big each DNA particle is. The bigger the DNA particle is, the farther it will go through the gel. So you can see in this example here, this DNA particle went the farthest, which means that this piece of DNA is the biggest DNA in the entire bunch. And the reason that happens is because of this power source. And can anybody tell me which one of these 1, 2, 3, 4, 5 matches with X? Tell me through chat. This is actually quite hard.
Can we put only one?
Yeah, there can only be one. Okay, yeah, I'm getting there's actually so many different possible answers for this. As I said before, DNA is super inaccurate because of how similar each person's DNA is. You can see that 2 and 4 both could possibly correspond. 1 could also correspond. So 1, 2, and 4 are all possibly correct answers. And that's because everyone's DNA is just so similar. I personally say that it's probably 2, but 2 and 4 are both really similar. And that concludes section 2. And here I'm going to talk about final analysis. And that's when you say which suspects committed the crime and why will he or they commit the crime. And you have to include evidence too. So you can say that we believe.
The motive.
Yeah, you also need to include the motive too. Great observation. So the motive is like, for example, suspect A wanted to steal the scantrons from Mr. Calculus because she knew that they had a super bad math score and thus did not want his or her grade to fall down to a C. Or it might also be suspect B stole the scantrons because she really hates Mr. Calculus for putting she in trouble last week. And you have to include evidence.
Do that?
I don't know, it's just like a hypothetical situation. Ask the test writers, not me. And including evidence can sound something like, we found lemon juice evidence dried on one of the student desks, and that lemon juice corresponds to the lemon juice that suspect D drank that afternoon, according to our observations. And that is why we think that suspect D was the person who committed the crime. And then you have to include why other suspects did not commit the crime. For example, suspect C's only possible motive was that she was a bit sad yesterday that she lost in like some random game. That is a super weak motive because it doesn't have any monetary motive to it. And not only that, we did not seem to find any evidence at all corresponding to that suspect. And then we have to do the reconstruction of the crime. That can be something like, based on all our observations, we believe that suspect B and suspect D committed a crime. On that afternoon, while Mr. Calculus was getting his coffee at the teacher's lounge, they snuck into his office and stole the scantrons and then burned them. So that's something that could be
Wait, they
the
stole the
reconstruction.
what?
The scantrons. You know, I don't know if you use scantrons. They're just like bubble shades.
They're what?
Bubble sheets. Yeah, I'm getting lots of funny things in the chat. Yeah, those are all like possible like hypotheticals that can happen for the reconstruction of the crime. Sometimes you do have to do some imagining. And I think, yeah, we can go to the Kahoot right now. So before the Kahoot happens, I'd like everyone to have access to the cheat sheet that you will need this for the Kahoot. I'll send it in chat real quick. So sorry. Yeah, so everyone please go to on the doc. It has the charts for powders, liquids, and metals, and you will need this for the Kahoot. Okay, so I'm just going to wait till everyone has access. I'll just share the link once more if you lost it. Okay, I think enough people have gotten access to this. Actually, no, I don't think enough people. There's 116 participants and only 57 have access. I'll share the link once again. So you will need this document for the Kahoot. Without this document, you can only guess. And I'll also get the Kahoot running. Someone just mentioned that they can't see the doc without going out of Kahoot. Super sorry. I think you can try to do a split screen, but if you can't, just like alternate windows. I think I gave enough like time for each question, so you should have time to alternate. There's some kind of funny names in here. Hey, science is
Like that
not
setting
dumb.
on for the show thing on player screens.
Can you repeat that?
Like, is the setting on for the show enter to some players' screens on?
Suspense.
I don't know what you're talking about. Can you repeat that question?
Like the show answer choices thing.
Yeah, I
Why
think I
does
already,
why does like
yeah,
no
I
one
turned it
why
on already.
why does no one like science?
Yeah, I'm really disappointed in some of you. Science is really
Wow.
fun.
I love science.
Maybe.
What the heck is DFS?
Even
Okay,
someone named Person.
Wow, what a creative name.
Well, they're not
Wait,
wrong.
seriously, there's Alka-Seltzer in here?
Well, they're not wrong.
No, I
Yeah,
mean, like, there's Alka-Seltzer in the powders thing.
There's two
Okay.
highs.
Okay,
This
we're,
Congratu-
So is
Congratulations. You do
Okay,
not know anything about guns.
okay.
Car 98K
Car
is a
98K
semi-automatic
is
bolt
a-
action rifle.
okay, so I put the link once again in the chat.
Science sucks. Science so sucks.
So I'm just going to start it right now.
What about it?
So
Be
remember,
like two
Wow.
people joined to do that on purpose.
Friendless.
remember to first refer to the cheat sheet doc, which is in chat for the first few identification questions. Okay, I'm just gonna start it now. Remember to look at the doc.
The picture is beautiful.
Thank you.
That just looks satisfying.
I know. You should watch the Mark Rober video about it. It's
Mustard
awesome.
mint.
It's the elephant.
Okay,
tooth
awesome. I
video.
appreciate that 64 of you decided to.
1 point behind Boo Science, apparently.
Okay, we don't need to know that.
1 point behind Ian.
1 point
Uh,
behind.
so-
1 point
You
behind
can
dot.
see here that for Alka-Seltzer, it does fit with almost everything, including HCl, iodine, and water. So for Crimebusters, just know that Alka-Seltzer reacts with like every liquid. Good job to 64 of you, and good job to Kayla. I think I already gave away this answer.
You shouldn't have said like the last few words when you prepared the documents.
I mean, it is in the cheat sheet, so
How tall is that thing?
And it's in
What
the picture, so I
did
mean,
he put in there?
Is that
one?
elephant toothpaste?
Yeah, I think it is elephant toothpaste.
best thing to do.
Okay, I like
turn
this.
coffee
So
grounds into
73 of you
Alka-Seltzer.
73 of you decided to listen to me and understand that Alka-Seltzer reacts with basically all the liquids, including water. Good job.
I'm 10 points behind Science Sucks.
I don't know what I just pressed.
Oh, so sugar. I don't know why you'll decide to choose sugar. Sugar does not have that much like that low of an acidity. It's not that basic. Yeah, sodium acetate. I think I provided that as an example. So good job to 40 of you. And good job to this nickname. So take note of the last part which says it smells like bread. Okay, great. So yeah, yeast is found in basically all types of bread, and that is why it says it smells like bread. Sand does not smell like bread at all. I mean, yeah, I don't think it smells like bread. So does Alka-Seltzer. I don't think Alka-Seltzer smells like bread. Anyways, good job, Blair. I'm super sorry to those people who did not have enough time to click. It's my fault that I didn't make it like in a minute. Super sorry. Okay, yeah, so it's lemon juice because it smells like lemons and it's pretty acidic and it's pretty yellowish. I don't know why you'll choose apple juice because if you refer back to the chart here, apple juice isn't anywhere on the liquids chart. Don't choose urine, and vinegar does not like smell like lemons. Okay, great. Less people got this time. Why will you choose Sprite? It's not even on the chart. If you look at the chart, there's no Sprite anywhere here. Rubbing alcohol not only like smells a bit sweet, but you can see that it has a pretty neutral pH and it smells like alcohol. So make sure to actually look at the charts and not to just randomly guess. And remember that this metal is magnetic. I'm not magnetic, sorry. Yay, so lots of you got this thing right this time. Aluminum is gray and it is one of the lightest metals on Earth, unlike some of these other ones. Good job. Good job to Detective Bunny. So by this point, you don't need that cheat sheet anymore. Ooh, so this time I think this question might be a bit hard. Wait, I think I got this wrong. Actually, I think the actual correct answer should be cat. I'm super sorry, because there was like little like circle things within the hair itself. I don't know why I put dog as answer. I'm super sorry, everyone. I'm super sorry. If you chose cat, you are the real winner. Yeah, great. So, um, the image isn't there. Oh, here it is. So the image here, you can see that it is really smooth and it is surprisingly super straight. And that's not the stuff that natural fiber is. Natural fiber is super rough and it's twisted and like not like bent and all that stuff. So it has to be a type of synthetic fiber or artificial fiber. Oh, so this seemed like a pretty tough question. So, as I said before, the size is what dictates how far a DNA will travel within the gel. Ian, you can just say your question right now. And basically, if the DNA particle is big, then that piece of DNA will travel even farther. Okay, Ian, you can see your question right now.
This is for the dog hair, cat hair thing.
Mhm.
Wasn't that one supposedly a dog hair because like the outside wasn't rough, like the bark pretty
Ooh,
much?
I don't know.
Wasn't rough.
The
It was
interior looked like cat hair to me. Yeah, that's a mistake on my part.
maybe hybrid, maybe like a, well, to be honest, I mean, like we can't be too sure
Okay.
because there's some types of fur that are more like cats and some.
Okay, yeah. Yeah, it's my fault. Anyways, gel
Yes, no.
electrophoresis purely depends on the size of DNA. What were you saying?
I look at the picture. It does not look like any of them actually.
That's interesting. Okay. Yeah, I'll research on that. Good job. Good job, Ian. Yeah, so in that image, you can see that when the ink was actually going down, and the yellow ink didn't clearly was able to bond with the solvent such as water or alcohol much more better than the black ink, which didn't bond to water as well, which means that it wasn't able to travel down the paper as well. Of course, gravity will have like some effect on it, but I don't think gravity is like big enough to actually make some considerable impact. Sorry for going over time right now. This is the last question. For this question, pick 2 answers. Okay, great. So the 2 things that you must need to include is possible motives and brief reconstruction of the crimes. There is never ever witness statements in a test itself. And of course you can like really quickly summarize each suspect, but that's not required. All you have to say is just something like suspect A's motive was so and so, and we believe that he did the crime. On Friday, this is what he did. So brief reconstruction and the possible motives are all required. And that's the end. Good job, Glenda. Good job, Daphne. Okay, good job, Ian. Okay, thank you for coming to this class today. And you can leave now.
Thank you.
Bye.
Bye.
Thank
Thank
you.
you,
Bye.
Thank you.
Catch you
Bye.
later.
Bye.
Bye bye.
Sixth place.